Hey, you guys, this is Mrs. Allday, Algebra 2 General, Remote Online Learning for Charles High School. This is day 2 of 7-7. Now, 7-7 is the inverse relations and functions. So you need to get out your notes for that. There were 4 pages for these notes. 2 of them we did yesterday, and then 2 of them we're doing today. All right, so go ahead and get your pages of notes out, or if you're doing this in your spiral composition notebook, then if you would open it up. All right, so we're going to get started. All right, so we're still talking about inverse relations. So up at the top, you can see that it says this f to the negative 1. When you see that, you don't really read it like that. You read it as the inverse of f or f inverse. So I'm going to write it over here to the right, and let's say it, f inverse. So that's pretty easy. All right, so remember that while f of x is a function, the inverse, f inverse, may not be a function. And we actually figured that out yesterday whenever we were doing this, because we were doing parabolas and they were functions. But then we went and we swapped them and did the inverse, and it ended up being a sideways parabola, and that definitely was not a function. All right, so today let's look at functions and their inverses again. All right, so the first example, I'm going to call this example number 1 in case you're writing it in your spiral composition notebook. If we want to figure out what the domain is, think about it. That's the x values. So go where the x is. Take that off to the side, x minus 2. And I want you to put that it's greater than or equal to 0. Now let me tell you why it's greater than or equal to 0. Because we don't want to graph anything in here that's an imaginary number. We're graphing on an x-y coordinate plane. And if anything in there ends up being less than 0, then it's going to be an imaginary number, because the square root of a negative number is an imaginary number. So that's why what's underneath the radical will be greater than or equal to 0. So now let's solve it. We're going to add 2 to both sides. Cancel out. We have x is greater than or equal to 2. All right, that's our domain. X is anything that is greater than or equal to 2. All right, so that was my work to get my domain. All right, now, what do we do to get the range? All right, we're going to do a little table here. And what we're going to do is we're going to take the domain, and if we put it in here, now remember, f of x is also y. So this is really y equals the square root of 2 minus 2. Well, we know that 2 minus 2 is 0. Okay, and the square root of 0, I guess, is 0. Okay, so if x is 2, then y is 0. Well, let's think of another number that's greater than or equal to 2. Let's do 3. All right, so 3. 3 minus 2 is 1, and the square root of 1 is 1. So if I put a 3 into this problem, I end up getting a 1. So 3, 1. All right, what comes after 3? Something greater than or equal to 2? Well, we could do 4. But if I did 4, I would get the square root of 2, and I'm not really quite sure what that is. It's 1 point something. So let's think of something that would make what's underneath the radical a perfect square. So I didn't do 4. Would 5 make it a perfect square? 5 minus 2 is 3. No, 3 is not a perfect square. So would 6 make it a perfect square? 6 minus 2 is 4. That works. So if I put the x value as 6, 6 minus 2 is 4, and the square root of 4 is 2. I want you to notice something. I'm going to do this in neon green so you can see it. What's happening to the range? Is it getting larger or greater than 0? So while you're answering that, I'm going to come over here and say y is, and I can tell that all these numbers are getting greater than or equal to 0. So that's going to be my range. So that's one way of doing it. In a little bit, you're going to figure out there might be another easier way. But I want to make sure you understand that way first. Always learn the harder way first. That way the easier way makes sense later. All right, what are the domain and range of f inverse? All right, let's do this in purple, my favorite color. So the domain is still going to be x, and the range is still going to be y. But remember, when you're doing the inverse, you are switching these two. So if the domain of the original function is greater than or equal to 2, you're going to take that and you're going to put it in the range. So the range is going to be greater than or equal to 2. But remember, the range is still y. That part doesn't change. All right, for x, I'm going to have to go find the range, which y is greater than or equal to 0. And I'm going to have to take that greater than or equal to 0 and put it where the domain is for the inverse, because we swap the x and the y. So x is greater than or equal to 0. Well, that was easy. All we did was swap them, just like we did yesterday, except we're kind of swapping more of an expression. But remember, the domain still has to be x, and the range still has to be y. That doesn't change. All right, what is the inverse of f? All right, let's see. We're going to take this right here, and I want you to remember that this is really y equals the square root of x minus 2. So down here for letter C, when it says, what is f inverse? Remember, we have to switch the x and the y. All right, so let me do this in green. So I'm literally switching the x and the y. So I'm putting the x where the y is, equals the square root, and I'm putting the y where the x is. Okay, well that's good, but we have to solve for y. Well, what's the opposite of square rooting something? That's going to be squaring something. All right, so we're going to square both sides, because whatever you do to one side, you have to do to the other. Now, why am I squaring it? Because I cannot get the y out of the radical unless I square it. All right, so I have x squared equals y minus 2. Okay, I almost have y by itself. This is good. I'm going to add 2 to both sides. These cancel out. I have y equals x squared plus 2. So now I'm going to write it using f inverse. So I'm going to say the inverse of f is x squared plus 2. So you could write it like I did here, or you could write it like I did here. Okay, because they said, what is the inverse of f? Well, there it is. Well, is it a function? Well, look at it. What does it look like? I see x squared. I don't see any radical. So x squared means it's a parabola. So, is f1 a function? Yes, it's a parabola, okay? So we're going to put that each x has exactly one y. Now, if you want to graph this, you can, if you don't believe me that it's a function. But look at it. If we have y equals x squared plus 2, remember that's your k. If I was going to graph it, I'm going to go, that tells me to either go up or down. So I'm going to go up 2. And if I was doing a sketch and it opens up, that's the way it looks. So, yep, that's a function. So just remember that if it's a parabola, if it's x squared, then it's going to be a function. All right, let's go to the next example. We're going to call this example 2 in case you're doing this in your spiral composition notebook. All right, you read this as g of x. It just means it's another problem. F of x was the first one we were doing. The next one we're doing is g of x, okay? It's like blue shirt, red shirt, okay? Two different things, but kind of the same. All right, what are the domain and range of g? Well, I want you to look at this problem. I want you to take g of x out just for a minute and think of it like this. 6 minus 4x. Let's put it in slope-intercept form. Y equals negative 4x plus 6. Look at there. What is that? That's a line. If that's in slope-intercept form, I see the slope is negative 4 and the y-intercept is 6. That's going to be a line. Okay, so we know what it is now. Let's see what they want us to do. What are the domain and range of g? Well, if this is a line, my domain is going to be all real numbers. You can either write it like that, or you can do all real numbers. Well, if the range is all real numbers, I'm sorry, the domain, I didn't mean to put range. The domain is all real numbers. Then the range is also going to be all real numbers because it's a line. Okay? When you go like this, and go like this, and then you go like this. That's the sign for all real numbers. Okay? Some people like to just put or all real numbers. Okay? Now, what are the domain and range of g inverse? Okay, well, all we got to do is switch those. Well, that's going to be easy. All real numbers and all real numbers. It's very easy. All right. What is G inverse? Well, let's go up here and look. Let's switch the place of the y and the x. I just did that in green if you wondered where it was. All right, so we're going to say x equals negative 4y plus 6. All right, remember your next step is to solve for y. Okay. All right, so I got to get y by itself. So I'm going to subtract 6 from both sides. The reason why I don't put minus 6 here is because those are not like terms. I like to line up like terms. All right, so we have x minus 6 equals negative 4y. All right, we're going to divide every single thing by negative 4. Remember, put a 1 here because it makes it look nicer. Makes it make sense, really. So cancel those out. I have y equals negative 1/4 x. Now, a negative divided by a negative is going to make this a positive. And I'm going to go ahead and reduce the 6/4. So I'm going to divide them both by 2. That's going to give me 3/2 plus 3/2. All right. That is G inverse. Now, I can erase this y, and I could put the inverse of G. That's supposed to be a negative 1. Let me make it look like a negative 1. All right, now let me show you another answer that you could have got for this, and it would have been just fine. Okay, so I'm going to back up a little bit just so you know what could be an okay answer, because that's not the only answer for this. All right, I'm going to do it in purple. All right, I had negative 4y equals x minus 6. Now, if I divide by negative 4, I can put this whole thing over negative 4 if I wanted to, and I can make it look like this. Y equals x minus 6 over negative 4, but you're not supposed to have a negative in the denominator. So that means you would have to move it up here, and to move it up here, you would have to put the negative out in front. So you could actually have y equals, I'm going to distribute the negative, negative x plus 6 over 4. But if you had that, it's going to be hard for you to do the next question. Is G inverse a function? I don't know if you could tell by looking at it like that. So I just want you to know that is another way you could write the inverse of G. All right, so let's go to G inverse and let's look at it and let's see if it's a function. We're just going to look at what type of function is this, or what type of relation is this. So if I look at it right here, it looks like y equals mx plus b. Okay, it is. It's slope-intercept form. So it's a line. Well, are lines functions? Yep, as long as it's not a vertical line, and that's not a vertical line. Okay, so is g of negative 1 a function? Yes. And we're going to say each x has exactly 1 y. And if you wanted to prove it, you could graph it and you would see. All right, let's go to the next example. Before we do, at the very bottom of this page, and I said this yesterday, if a relation and its inverse are both functions, then we call it a one-to-one function. All right, so let's go back up to the top. We looked at the first one, and it said it was a function. Okay, so because it said this, it said f of x, that means it was a function. Okay, so the original was a function. And then when we got down to the inverse, it was a function. So that's a one-to-one function. It's kind of like, okay, this one's a function and this one's a function. So it's called one-to-one function. All right, let's look at this one that we just did. Okay, the first one was y equals mx plus b form, and the second one was y equals mx plus b form. Okay, so they were both linear equations. So they were both functions. So that is also a one-to-one function. Okay? All right, go to the next page. This is our last page of notes for 6-7, and then tomorrow we'll move on to 6-8. When it comes to a function, its inverse, because their domain and range are swapped, what one does, the other undoes. It's kind of like if I added 2 to something, and you had the same thing. Okay, so if I said 5 plus 2 is 7. And I'm like, okay, I want you to undo what I just did. I just added 2 to 7. All right, well, let's subtract 2 from 7. You end up with what you started with. Okay, so that's why one undoes the other. Kind of like if you're solving this. 3x equals 6. If I divide both sides by 3, I'm undoing what was being done. They were multiplying 3 times x, and now I'm dividing. So it's kind of the same concept, but a little bit different. All right, so here's an example. If f adds 2 to the input, f of x, this is the original one, x plus 2, then the inverse of f will subtract 2 from the input. So here's the input, and they're subtracting 2 from it. All right, so that's just an example of that one undoes the other. All right, so we're going to find compositions. Now remember what compositions are. Compositions is not really multiplying, adding, dividing, subtracting, all that. It's more substitution, okay? So when you're looking at compositions, and this says f of negative 1 is 5, you come up here and you find the inverse, f inverse. So the inverse of f, I want you to substitute 5 in it. So you got to put 5 where the x is. So that's 5 minus 2. So we get 3. All right, so we found out what the inverse of f was. We take that 3 down and we input it, we substitute it into f of x. So now we're going to put 3 in the original one. So where x is where we're going to put 3. 3 plus 2 is 5. All right, let's look at the next one. The first thing we want to do is we want to do something with f inverse. So the inverse of f, we want to input 3. So I'm going to put 3 right here. So that's going to be 3 minus 2, which is 1. Now we're going to take that 1 and we're going to input it into f of x. So we're going to input 1. F of x is x plus 2. So it's going to be 1 plus 2, which is 3. All right, let's look at the next one. Use a different color, right? All right, we're going to start off with f of x. So we're starting off with this one. So we're going to input 6 wherever x is. So 6 plus 2 is 8. Now remember, if I'm going too fast, just pause me. All right, now we're going to take that 8 and we're going to input it into f inverse. So here's f inverse. So f inverse, we're going to substitute 8. So we're going to do 8 minus 2, which is 6. All right, we're going to start down here with f inverse, or the inverse of f. We're going to substitute x. Well, if we look up here, let me change a color. Let's do blue. If you look up here, it already has x in it. So I'm not really doing anything different for this problem except copying down what's already there. Now, you're going to take that x minus 2 and you're going to plug it into the f of x. So f of x minus 2. You have to take that x minus 2. I'm going to do this in green neon. And you have to put it right there where that x is. Okay, so I'm going to put x minus 2, but then there's still a plus 2 in the rest of that function. You just took the x minus 2 and you substituted it for x. So now think about it. What just happened? X minus 2 plus 2 is x, because the two 2's kind of cancel each other out. All right, let's take what f of x is. Okay, well, f of x, I'm going to insert x. Well, it's already like that. It's x plus 2. Okay, so it's kind of like we're just writing it again because it didn't change. We're going to take that x plus 2 and we're going to put it into f inverse. So f inverse is, we're going to insert x plus 2 wherever we see x. Okay, well, I see x right here in black. I circled it. X plus 2, but then there's a minus 2 still in f inverse. So those two kind of cancel each other out, and I'm left with x again. So we're kind of taking the compositions that we did the other day, and we're just blending it together with inverse relations and inverse functions. So let's see what really happened here when we were working those problems. If we had the inverse and we plugged it into the function, and we're plugging in x, we ended up getting x. Now, if we started off with the function, because we always start on the inside first, clean the inside of your house first before you go outside. and we plug it in to f inverse, and we're plugging in an x, we're going to end up with an x. Let's go back up here. I'm going to do this with blue. I started out with 5. I ended up with 5. I started out with 3. I ended up with 3. I started out with 6. I ended up with 6. I started out with x. I ended up with x. I started out with x, and I ended up with x. It's kind of like what you put into something, you get out of it. If you put a lot of work into something, you're going to get a lot out of it. That's a hint. Do your homework. All right. Find each of the following if f of x equals 3x plus 6. All right. So let's see what example. We didn't really number those examples. So I'll just start numbering again here. I'm going to call this A. All right. So for A, we have to find each of the following if f of x is 3x plus 6. But the first thing we have to do is we have to change that. Now remember, f of x is really y. And if they want us to do f inverse, then we've got to switch the x and the y. All right, so we're going to do that. We're going to switch. So it's going to be x equals 3y plus 6. Subtract 6 from both sides. We get 3y equals x minus 6. Divide by 3. I'm going to cross that out. And I have y equals x minus 6 over 3. Now I'm looking ahead, and they're not going to be asking me what the domain or the range is. They're not going to be asking me if it's a function. So I'm going to leave my problem like that. The only thing I'm going to do different is I'm going to put the inverse of f there. I'm going to exchange it for the y and put x minus 6 over 3. So this right here that I'm double boxing is my answer, because we're going to need that in a minute. Because if you look down here, we're going to call this B. This is the compositions just like we were doing the other day. See that little open circle right there? That means do the inverse first and then do the f of x. All right. Excuse me for a minute while I try to pause this, okay? Okay. I just had to find me another color up here to use. Thank you for being patient with me. All right, we're going to erase this just so we don't see all that stuff right now. All right, we're going to start off with this part. If you have to write it like this, that's what you're doing first. And then you're going to input that into the f of x. So it actually looks just like what we were doing up there. If you write the one that's closest to the x first, that's the one you have to do first. All right, so basically what that's saying is, okay, what's your inverse? If I input x in there, what's your inverse? Well, it's right up here. It is what it is. It is x minus 6 over 3. All right. Now, if you take that inverse of f, okay, and you go input it into f of x, okay, well, where's f of x? Okay, it's right way up here. So I'm going to take that x minus 6, and I'm going to input it into f of x. That just tells me that's what I'm going to input. I have to put it right there where that x is. So it's going to be 3 times x minus 6 over 3, close parentheses, and then it has a plus 6. So I'm just inputting the inverse into the original function. All right, let's see what happens here. Do you see that these two cancel out? And you're left with x minus 6 plus 6. And then the 6's, the negative 6 and the 6 cancels out, and you're left with x. Well, think about it. What did you put into the problem? X. What did you get out of the problem? X. Okay, it's kind of like, what do you put into your work? A lot of hard work? Then you're going to get an A, right? All right, let's go to this next one. We're going to rewrite it so it looks like the ones above. This one we have to do first. So we have to do f of x first, and then we're going to input it into the inverse of f. All right, so let's go find f of x first. All right, well, that's up above there. That's 3x plus 6. We're not doing anything when they put x in there. We're writing the same thing again. All right, Now I have to take that 3x plus 6 and go put it into the inverse of f. So the inverse of f, I'm inserting into it 3x plus 6. So that means right here where that x is, I have to put 3x plus 6 in its spot. 3x plus 6. But then I have to put minus 6. And then I have to put it all over 3. All right, let's check this out for a minute. Those 6's cancel each other out. So I have 3x over 3. Well, the 3's cancel out. So I have x. What did I put in to the problem? I put x in. What did I get out? I got x out. But you have to show this work. You can't just say, well, I put the function in the inverse, and so I got the same thing I put in. Or you can't say, I put the inverse in the function, and so I got the same thing I put in. Can't do that. All right. Let's erase here a little bit, and let's do our last problem. I think I forgot to number or letter them as we were going, so sorry. Hopefully you did that on your own. You guys got this. All right, so this last problem says, for the inverse, I want you to put in -2. All right, so my inverse is y equals x minus 6 over 3. I could erase the y, and I could say f inverse. Okay, so that's where I have to put the -2 at. Okay, so -2 minus 6 over 3. That's -8 over 3. All right, now I have to take what I get with that, and I have to put it into the function. All right, so I'm going to put -8/3 into the function. All right, what's the function? It's way up there. It is f of x equals 3x plus 6. Okay, so I'm going to take the -8/3, and instead of 3x plus 6, I'm going to put 3 times -8/3 plus 6. All right, look, the 3's cancel out. So I have -8 plus 6. What does that equal? -2. That's my answer. What did I put into this problem? Boom. I put into this problem -2. What did I get out of it? Boom. -2. All right, now we are finished with 6-7. Hi. And I'm going to go down here. I'm going to pull up this and just kind of show you where we're at in the scheme of things. All right. You see where it says April the 2nd, 6-7, inverse relations and functions, compositions. Your homework is page 410, problems 30 through 35 all, and 38 through 41 all. So you'll do that homework assignment, and you'll show your work, and then the mandatory upload is going to be 6.7 standardized test prep worksheet. You're going to do the worksheet, and you're going to upload it to Focus. Now you should have already done this already when you finished 6-6. So you should have already that worksheet uploaded. You're going to do 6-7. You're going to upload that one. That's where your grades come from. So for 6-6 and 6-7, just to review, you're writing in pen for these uploads because we can see that better whenever you take a picture of it and upload it. We can see pen better than we can pencil. All right? So you're doing it in pen. You're writing your name on it. You're writing the date on it. So you're writing April the 2nd. You're putting whatever class period you're in, whatever teacher you have, and you're putting Algebra 2. And you're going to put a piece of notebook paper right beside you and put those same things. Put your name and pen, put your date, put your teacher, put your assignment. You need to put 6-7 test prep worksheet. And then number 1, show your work. Then go circle your answer. Number 2, show your work. Go circle your answer. Okay, when you get to the end, okay, you're going to say, I have watched the videos, taken the notes, and done my homework. And you're going to sign your name. That's what you're going to do on the bottom of the worksheet. You got your worksheet. You got your work that you showed for your worksheet. You have everything done that I've asked you to do. I thank you so much for doing this. I know you're doing a good job. You are going to upload them, but this is very important. Do not upload them as a picture. Upload them as a document. So either upload it in Word or upload it as a PDF. A PDF will be fine. upload that into Focus. So you should have 2 pages that you upload for every test prep worksheet. Try to do all your work on one page and number it and make it neat. Like go down on the left-hand side and do 1, 2, 3, 4, 5, and then go up on the right-hand side and do 5, 6, 7, 8, whatever it is. You're only doing the multiple choice items. So if there's an open response, you don't have to do it. Okay? All right. So that's it. You guys got what you're going to do. Tomorrow is Friday, and we're going to do 6-8. You're going to have a new handout to do for that. And then you're going to have a mandatory upload. So by the end of the weekend, when you start school back on Monday, on April the 6th, you need to have all your homeworks done. You should have watched all of your videos, and you should have done all your uploads. So if you look at this chart right now, you don't see my YouTube videos popping up for today. That's because I'm doing it right now. I go at it after I do it. All right, you guys, you've probably heard enough of me. So I'm going to tell you bye, and I'll see you tomorrow.